Good evening, and welcome back to Boring Science for Sleep. Tonight, we are going to drift somewhere very quiet, somewhere deep, somewhere few people have ever truly seen. So, if you can, dim the lights around you, settle into a comfortable position, and allow your mind to slow down. Take a slow breath in and gently let it out, because tonight, we are going beneath the surface of the ocean, into a hidden world of fire and water. Imagine standing beside the sea long after sunset. The sky above you is calm and filled with stars. The wind is soft, and the waves move slowly across the sand. The ocean appears peaceful, endless, quiet, dark and still beneath the moonlight. From the surface, it feels like the most tranquil place on Earth. But far below those gentle waves, beyond the reach of sunlight, beyond the places where ships sail and whales swim, there exists another world entirely. A world of mountains, a world of fire, a world where the Earth itself is constantly changing. Because deep beneath the ocean, hidden beneath miles of dark water, there are volcanoes, enormous mountains made of magma and stone. Some of them are taller than the mountains we see on land. Some rise thousands of meters from the seafloor, towering silently through the darkness of the deep ocean. And yet, most people never think about them. When we imagine volcanoes, we picture mountains like Mount Fuji or Mount Etna or the fiery landscapes of Hawaii. But the truth is something much more surprising. Most of the volcanoes on Earth are not on land at all. They are hidden beneath the sea. In fact, the ocean floor is covered with an enormous chain of underwater volcanoes, a vast network of volcanic mountains stretching across the planet. Some erupt slowly, releasing glowing lava into the cold black ocean. Others quietly build new pieces of Earth's crust, layer by layer, over millions of years. And sometimes, rarely but dramatically, an underwater volcano grows so large that it rises above the ocean's surface, forming a brand new island. But most of the time, these volcanoes remain unseen. They erupt in silence beneath kilometers of water, surrounded only by darkness and strange deep-sea creatures. In these hidden places, lava flows across the seafloor like glowing rivers. Superheated water bursts from cracks in the earth, and entire ecosystems of unusual life gather around volcanic vents, thriving in places where sunlight never reaches. It is a world both peaceful and powerful, a world where fire and water exist together. And tonight, we are going to explore it slowly. Over the course of this journey, we will discover 100 sleepy facts about underwater volcanoes. We will travel along the vast mountain chains of the mid-ocean ridges, watch lava meet the cold ocean and form strange pillow-shaped rocks, visit hydrothermal vents where life flourishes in complete darkness, and explore the hidden mountains that slowly build new pieces of our planet beneath the waves. All while the quiet ocean above remains calm and still. But before we begin our descent into the deep sea, I'd love to know something. Where in the world are you listening from tonight? And what time is it there right now? Some of you may be listening late at night, others early in the morning, and some perhaps drifting towards sleep in the middle of the afternoon. Wherever you are, I'm glad you're here. Now, let your breathing slow. Imagine the ocean once more, the moon shining softly above the water, and beneath the quiet waves, far below the surface, mountains of fire rising slowly in the darkness. Because in the next few moments, we are going to descend gently into the deep, into the hidden world of underwater volcanoes. As we begin our quiet journey tonight, imagine the surface of the ocean once more. From above, the sea seems smooth and peaceful. Moonlight glides across the water. The waves move slowly, almost lazily, toward the shore. It is easy to believe that the ocean floor beneath that calm surface must be just as still. But far below, beyond the reach of sunlight, beyond the depth where even whales rarely travel, the earth is alive with motion. The ocean floor is not flat. It is not empty. And it is certainly not quiet. Hidden beneath the sea lies a vast landscape of mountains, valleys, and volcanoes, an enormous geological world that stretches across the entire planet. And, surprisingly, most of Earth's volcanoes are not on land at all. They are beneath the ocean. If you could drain the oceans and reveal the seafloor, the view would be astonishing. You would see a rugged terrain filled with towering volcanic mountains rising from the darkness. Some of these underwater volcanoes are small, no larger than hills. Others are enormous, rivaling the tallest mountains on Earth. Many of them rise several kilometers from the seabed, their peaks hidden far below the ocean's surface. Yet because they remain underwater, most people never realize just how many volcanoes exist across our planet. Scientists estimate that hundreds of thousands of underwater volcanoes may be scattered across the ocean floor. Many remain unexplored. Some have never even been mapped. They rest quietly in the darkness, slowly shaping the earth beneath the waves. One of the most remarkable features of our planet lies deep beneath the oceans. It is called the mid-ocean ridge. This enormous chain of underwater mountains wraps around the earth like the seams of a giant baseball. Stretching more than 60,000 kilometers, it is the longest mountain range on the planet, and nearly all of it lies hidden beneath the sea. Along this vast ridge, the Earth's crust is constantly changing. Deep within the planet, molten rock magma slowly rises upward. When it reaches the ocean floor, it cools and hardens, forming brand new crust. In this way, underwater volcanoes quietly build the surface of our planet, layer by layer, year after year. For millions of years, these volcanic ridges are not violent places most of the time. In fact, they are often surprisingly gentle. Instead of explosive eruptions, many underwater volcanoes release lava slowly, allowing it to flow across the seabed like thick, glowing rivers. The cold ocean water quickly cools the molten rock. As the lava hardens, it forms strange rounded shapes known as pillow lava, which look almost like giant stacks of stone cushions scattered across the seafloor. Over time, countless eruptions slowly expand the ocean floor outward. It is a quiet process, almost peaceful when imagined over geological time. But it is one of the most important processes shaping our planet. The ocean floor itself is constantly moving. This movement happens because the Earth's outer shell, the crust, is broken into enormous pieces called tectonic plates. These plates drift slowly across the surface of the planet. At the mid-ocean ridges, plates pull apart. And when they do, magma rises to fill the gap. Each new eruption creates fresh rock, slowly pushing the plates away from each other. It is a slow and steady process. The ocean floor spreads outward by just a few centimeters each year, about as fast as your fingernails grow. Yet over millions of years, this movement reshapes entire oceans. Because these volcanic ridges stretch across the entire globe, underwater volcanoes are constantly active somewhere on Earth. At any given moment, magma may be rising beneath the Atlantic Ocean, or beneath the Pacific, or beneath the Indian Ocean. In most cases, these eruptions are so deep beneath the sea that no one on the surface even notices. There is no towering plume of ash, no dramatic explosion lighting the sky, just molten rock meeting cold water far below the surface, the Earth quietly renewing itself in the darkness. Yet this hidden volcanic activity has enormous consequences for the planet. It creates new ocean floor. It releases heat from deep within the Earth. It drives the movement of tectonic plates, and it helps shape the continents themselves. Without underwater volcanoes, the Earth would look very different. The oceans might not exist in the same way. The continents might not drift, and many of the geological processes that make our planet dynamic and alive would simply stop. But what makes underwater volcanoes even more fascinating is that they form entire landscapes we rarely see. The ocean floor contains volcanic mountains known as seamounts. Some of these mountains are so tall that, if placed on land, they would rival the great peaks of the Himalayas. Yet their summits remain hidden beneath kilometers of water. Some are sharp and steep. Others are ancient and worn down by currents and time. Each one tells the story of eruptions that happened long ago in the darkness of the deep sea. In some rare cases, an underwater volcano grows so large that it finally reaches the surface. When this happens, something extraordinary occurs. A new island is born. This is how many volcanic islands form, including parts of Hawaii and Iceland. What begins as a hidden volcano beneath the ocean slowly builds upward, eruption by eruption, until one day it rises above the waves. But before that moment arrives, the volcano may spend thousands or even millions of years hidden beneath the sea, quietly growing in the darkness. When we look across the ocean at night, the water appears endless and calm. But beneath that calm surface lies an entire world of volcanic mountains, spreading ridges, and hidden eruptions. A world where the Earth itself continues to reshape its surface. Slowly, silently, and endlessly. And as we continue our journey tonight, we will travel deeper into this hidden world, because the underwater volcanoes we have just discovered are only the beginning. Soon, we will explore the vast mid-ocean ridges themselves, the enormous volcanic mountain chains that stretch across the seafloor like the backbone of our planet. And in those deep places, we will discover how the Earth quietly builds new crust beneath the ocean, one eruption at a time. Now that we have discovered that most volcanoes lie hidden beneath the sea, our journey tonight takes us even deeper into one of the most extraordinary geological structures on Earth. Imagine again that the oceans disappear for a moment. The vast blue waters fade away, revealing the seafloor beneath. What you would see stretching across the planet is something immense, something so large that it circles the entire globe. A chain of mountains longer than any range on land. These mountains form what scientists call the mid-ocean ridges, and they are the longest mountain system on Earth. The mid-ocean ridges form a continuous network of volcanic mountains that run through every major ocean, from the Arctic Ocean, through the Atlantic, across the Indian Ocean, and into the vast Pacific Basin. Together, these underwater mountains stretch more than 60,000 kilometers around the planet. To imagine their scale, consider this. The Andes Mountains in South America are one of the longest ranges on land. They stretch about 7,000 kilometers. The mid-ocean ridge system is nearly 10 times longer, and almost all of it lies hidden beneath thousands of meters of ocean water. Along these ridges, something remarkable is happening all the time. The Earth's crust is slowly being created. Deep beneath the ocean floor lies the mantle, a vast layer of hot, slowly moving rock. In certain places along the ridges, the tectonic plates that make up Earth's outer shell begin to drift apart. They separate slowly, almost imperceptibly, only a few centimeters each year. But when they pull apart, something from deep within the Earth rises upward to fill the space. Molten rock. Magma. As this magma reaches the seafloor, it cools rapidly in the icy water of the deep ocean. The molten rock hardens into new crust. Layer by layer, eruption by eruption, fresh rock forms at the ridges. This process is called seafloor spreading, and it is one of the most important geological processes shaping our planet. If you could watch this process in slow motion over millions of years, you would see the ocean floor slowly moving outward from the ridge like a conveyor belt. New rock forms at the center. Older rock gradually drifts away. Over time, entire ocean basins are created in this quiet and continuous way. The Earth is constantly renewing its surface beneath the oceans. What makes the mid-ocean ridges even more fascinating is their shape. They are not simply straight mountain chains. Instead, they are broken by deep valleys, jagged volcanic peaks, and long fractures in the crust. At the center of many ridges lies a deep crack known as a rift valley. This valley marks the exact place where tectonic plates are pulling apart. From this narrow line in the seafloor, magma rises and new crust forms. The process is slow and steady, but it has been shaping the planet for hundreds of millions of years. The ridges themselves can rise thousands of meters above the surrounding seafloor. Although they remain hidden beneath the ocean, they are enormous. In some places, the mid-ocean ridge rises so high that its peaks approach the ocean surface. In rare cases, volcanic activity pushes part of the ridge above the sea, creating volcanic islands. Iceland is one of the most famous examples. That island sits directly on top of the mid-Atlantic ridge, where the plates of North America and Europe slowly drift apart. Standing there, you are literally standing on the boundary between continents. But far more of this mountain chain remains unseen. Most of the ridge system lies deep beneath dark ocean water, where sunlight never reaches. Here, the landscape is dramatic and otherworldly. Volcanic peaks rise from the seafloor. Fresh lava flows spread across the rock, and cracks in the crust release heat and minerals from deep inside the earth. In these remote places, the Earth is still building itself. Despite their size, the mid-ocean ridges were not fully discovered until the 20th century. For centuries, humans explored the oceans without realizing what lay beneath them. It was only when scientists began mapping the seafloor using sonar that the enormous ridge system became clear. The maps revealed a mountain chain running across the entire planet. A geological structure larger than any mountain range we see on land, hidden beneath the sea all along. Today, we know that these ridges are responsible for creating much of the ocean floor itself. Most of the crust beneath the oceans formed from volcanic eruptions along these ridges. Each eruption adds a thin layer of new rock. Over millions of years, those layers accumulate, expanding the seafloor and reshaping the oceans. It is a quiet but powerful process, one that has been shaping our planet for hundreds of millions of years. And yet, the most fascinating part of the mid-ocean ridges may be what happens when molten lava meets the freezing water of the deep sea. When these two powerful forces collide, something extraordinary occurs. The lava cools instantly, forming strange rounded rocks that resemble enormous piles of stone pillows. These formations are known as pillow lava. They are among the most distinctive features of underwater volcanic eruptions, and they reveal exactly how lava behaves when it erupts beneath the sea. So as we continue drifting deeper into this hidden world tonight, we will soon witness what happens at the very moment when molten rock meets the cold ocean. A quiet collision of fire and water, a meeting that creates one of the most unusual rock formations on Earth. Because in our next segment, we will explore the moment when lava meets the ocean. As we continue our gentle descent into the hidden volcanic world beneath the sea, imagine once again the silent darkness of the deep ocean. Far below the waves, deeper than sunlight can travel, the sea floor stretches out in vast plains of dark rock. The water here is cold, very cold, just a few degrees above freezing. The pressure is immense, and for the most part, the deep ocean is quiet and still. But occasionally, in certain places along the sea floor, something extraordinary happens. From cracks in the Earth's crust, glowing molten rock begins to emerge. Lava. When we think of lava, we often imagine rivers of fire flowing down the slopes of volcanoes on land. Bright orange rock moving slowly through forests or across fields of black volcanic stone. But beneath the ocean, lava behaves very differently. Because here, the moment lava touches the water, everything changes. The deep sea is cold enough to chill molten rock almost instantly. And when lava meets the ocean, the result is one of the most unusual geological formations on Earth. Imagine a stream of glowing lava slowly rising from a crack in the seafloor. The molten rock is incredibly hot, sometimes more than 1,100 degrees Celsius. It flows slowly outward, thick and heavy like liquid stone. But surrounding it is water that is near freezing. The moment the lava touches the seawater, the outer surface cools almost immediately. A thin shell of solid rock forms around the molten interior. Inside that shell, the lava continues to move, still hot, still flowing, still pushing forward. As the lava slowly squeezes through the hardened crust surrounding it, it begins to bulge outward. The outer shell stretches and expands. Eventually it cracks open, and a new bubble of molten rock pushes through. Each time this happens, a rounded shape forms. Over time, these shapes stack and pile upon one another. The result looks almost like a collection of giant stone cushions scattered across the ocean floor. These formations are called pillow lava. Pillow lava is one of the most distinctive signs of underwater volcanic eruptions. If you could walk across the seafloor in these places, something humans can only do with specialized submersibles, you would see fields of rounded, bulbous rocks. Each one formed from a moment when molten lava pushed outward into the freezing water. Some pillows are small, about the size of a basketball. Others are enormous, several meters across. Together they form strange and beautiful landscapes of rounded stone shapes. From above, pillow lava fields can look almost organic, like piles of giant bubbles frozen in time, or like smooth stones stacked by invisible hands across the seabed. Their surfaces are often dark and glassy, formed by the rapid cooling of molten rock. Sometimes the outer crust cracks and reveals the fine crystalline structure within. Every pillow tells the story of a moment when fire met water. The process of forming pillow lava is surprisingly gentle compared to many volcanic eruptions on land. Underwater eruptions rarely produce the towering explosions of ash and smoke we associate with volcanoes above sea level. The immense pressure of the ocean prevents gases in the magma from expanding violently. Instead, lava tends to flow slowly and steadily across the seafloor. The eruption may continue for hours or days, sometimes even longer. All the while, new pillows form one after another as molten rock continues to meet the cold ocean. Yet even though these eruptions may appear quiet, the contrast between lava and seawater creates dramatic effects. When lava first touches the ocean, the surrounding water may flash instantly into steam. Tiny explosions can occur as pockets of trapped water expand rapidly. Fragments of volcanic glass may shatter and scatter across the seafloor. This glassy material is called hyaloclastite, a word that describes rock formed when lava shatters upon contact with water. These fragments settle slowly through the dark ocean like volcanic snow. The deep ocean environment also preserves these formations in remarkable detail. Because currents are often gentle and erosion is slow, pillow lava can remain visible for millions of years. Submersible explorers have discovered enormous fields of these formations stretching for kilometers across the seafloor. Some appear fresh and newly formed. Others are ancient, covered with thin layers of sediment or colonized by deep-sea life. In these quiet volcanic landscapes, geology and biology slowly intertwine. In fact, pillow lava fields often become homes for unusual marine creatures. Small fish hide among the rounded stones. Deep-sea crabs crawl across the dark surfaces. And in some regions, entire ecosystems develop near volcanic vents where hot water escapes from the Earth's crust. But we will explore those strange ecosystems soon. For now, we remain focused on the meeting of lava and water. Another fascinating aspect of underwater lava flows is how quickly the molten rock loses its heat. On land, lava may remain molten for hours or even days as it slowly cools in the open air. But beneath the ocean, cooling happens far more rapidly. The surrounding water draws heat away from the lava almost instantly. The outer shell solidifies in seconds. The interior may remain molten for a short time, but eventually it too cools and hardens into basaltic rock. In this way, the ocean acts like a giant cooling system for the planet's volcanic activity. Despite the rapid cooling, underwater lava can still travel considerable distances before it solidifies completely. Some flows spread across the seafloor like slow-moving rivers of molten rock. As they advance, new pillow formations develop along the edges of the flow. The landscape gradually grows outward, one pillow at a time. Over thousands of eruptions and millions of years, these lava flows build enormous sections of the ocean floor. The seafloor we know today is largely the result of countless underwater eruptions like these. Sometimes the lava eruptions are so extensive that they create entirely new volcanic mountains. These mountains may begin as simple cracks in the seafloor releasing molten rock, but over time, repeated eruptions pile lava higher and higher. Eventually, a volcanic mound forms, then a ridge, then perhaps a towering underwater mountain rising thousands of meters above the surrounding seabed. Many of the seamounts scattered across the oceans began their lives in this quiet way through repeated underwater eruptions producing fields of pillow lava. One of the most remarkable things about pillow lava is that it allows geologists to recognize ancient underwater eruptions even on land. In some mountain ranges today, scientists have discovered rocks that clearly formed as pillow lava. This means that those rocks were once formed beneath the sea. Over millions of years, tectonic movements lifted them upward, raising former ocean floor high above sea level. In this way, pillow lava provides clues about the ancient history of the Earth. It reveals where oceans once existed and how the surface of our planet has changed across immense spans of time. So as we continue drifting through this peaceful exploration of underwater volcanoes, imagine once more the silent seafloor. In the darkness, molten lava slowly emerges from the Earth. It glows briefly as it meets the cold ocean water. Then it cools, hardens, and becomes part of the ever-growing crust of our planet. A quiet meeting of fire and water, a slow creation of stone beneath the sea. But the story of underwater volcanoes does not end with lava flows, because in many places along the seafloor something even stranger occurs. Hot mineral-rich water begins to rise from cracks in the crust. Dark plumes of heated fluid burst into the ocean, and around these vents, entire ecosystems thrive in complete darkness. In our next segment, we will visit one of the most extraordinary environments on Earth, the mysterious world of hydrothermal vents. As we continue drifting through the hidden volcanic landscapes beneath the ocean, we now arrive at one of the most extraordinary places on Earth. Imagine once again the deep ocean floor. The water here is cold and dark. Sunlight cannot reach this far below the surface. The pressure is immense. And yet, in certain places along the seafloor, the darkness is interrupted by towering columns that rise like chimneys from the rock. From these chimneys, clouds of dark, mineral-rich fluid pour into the ocean. These strange formations are known as hydrothermal vents, and they are among the most unusual geological features on our planet. Hydrothermal vents form in regions where underwater volcanic activity heats the ocean floor. Seawater slowly seeps down through cracks in the Earth's crust. As the water travels deeper into the rock, it approaches magma chambers hidden beneath the seafloor. There, the water is heated to extraordinary temperatures, sometimes more than 350 degrees Celsius. Yet despite this extreme heat, the water does not boil. The immense pressure of the deep ocean keeps it in liquid form. As the water heats, it begins to dissolve minerals from the surrounding rocks. Iron, copper, zinc, sulfur, dozens of different elements become mixed into the superheated fluid. Eventually, this mineral-rich water rises back toward the surface through fractures in the crust. When it emerges from the seafloor, it bursts into the cold ocean water. The sudden temperature change causes the dissolved minerals to crystallize. Tiny particles form instantly, creating thick, dark plumes that drift upward into the sea. This is why some hydrothermal vents are known as black smokers. If you could see a black smoker up close, it would resemble a towering chimney made of dark stone. Some are only a few meters tall. Others can grow more than 20 meters high, rising from the seafloor like underwater smokestacks. From their tops, thick clouds of black mineral particles billow into the surrounding water. The scene is both eerie and beautiful. Dark columns of mineral-rich fluid drifting slowly upward in the silent depths of the ocean. These vent chimneys do not form overnight. They grow gradually as minerals settle and harden around the openings where the hot water escapes. Over time, layers of metal-rich deposits accumulate. The chimney becomes taller and thicker. Some hydrothermal vent fields contain dozens of these structures clustered together, creating landscapes that resemble strange underwater cities. But what makes hydrothermal vents truly remarkable is not only the geology, it is the life that gathers around them. In most parts of the deep ocean, life is scarce. Without sunlight, the food chains that support life near the surface cannot exist. Plants cannot grow, and without plants, many animals cannot survive. Yet around hydrothermal vents, entire ecosystems thrive. Clusters of creatures gather around these chimneys in astonishing numbers. Giant tube worms stretch upward like pale red flowers. Strange shrimp swarm through the heated water. Crabs crawl across the mineral deposits. And unusual fish glide slowly through the vent fields, all living in total darkness. The secret to this thriving ecosystem lies in the chemicals released by the vents. Instead of relying on sunlight for energy, organisms here use a process called chemosynthesis. Certain bacteria can convert chemicals such as hydrogen sulfide released from the vents into energy. These microbes form the base of the food chain. They grow in thick mats along the vent chimneys and surrounding rocks. Larger organisms feed on the bacteria or form partnerships with them. For example, the giant tube worms that live near vents contain bacteria within their bodies. The bacteria produce nutrients through chemosynthesis, which feed the worms. It is a completely different kind of ecosystem, one that does not depend on sunlight at all. Some scientists believe that environments like hydrothermal vents may resemble conditions on the early Earth. Billions of years ago, before the atmosphere contained much oxygen and before complex life evolved, similar chemical processes may have supported the first living organisms. In fact, some researchers suggest that life itself may have begun in environments like these, deep in the ocean, near volcanic heat, powered not by sunlight, but by chemistry. Hydrothermal vents are also important for understanding how heat moves through our planet. The water circulating through the Earth's crust carries enormous amounts of geothermal energy. When it escapes through the vents, that heat is released into the surrounding ocean. Over time, this process helps regulate the temperature and chemistry of the ocean itself. It is another example of how volcanic activity beneath the sea quietly influences the entire planet. Exploring hydrothermal vents is not easy. Because they exist at extreme depths, often 2,000 to 4,000 meters below the surface, scientists must rely on specialized submersibles and robotic vehicles. These machines descend slowly through the darkness, carrying cameras and instruments. When their lights finally illuminate a vent field, the scene can look almost alien. Tall mineral chimneys, clouds of black smoke drifting through the water, and strange creatures moving slowly among the rocks. A hidden world that few humans have ever witnessed directly. Despite decades of exploration, scientists believe that many hydrothermal vent systems remain undiscovered. The ocean floor is vast, and much of it has never been mapped in detail. There may be entire vent ecosystems still waiting to be found in the darkness. Each one a reminder that our planet still holds many secrets beneath the sea. So as we continue drifting through the quiet volcanic landscapes of the deep ocean tonight, imagine standing beside one of these strange chimneys. Black mineral clouds rising slowly into the cold water, tiny creatures moving through the drifting plumes, and beneath it all, the steady warmth of Earth's inner heat rising toward the surface. A hidden meeting place of fire, water, minerals, and life. But hydrothermal vents are only one part of the remarkable ecosystems that surround underwater volcanoes. Because where there is volcanic heat, life often finds surprising ways to thrive. And in our next segment, we will explore the strange and fascinating creatures that live around underwater volcanoes, organisms that survive in one of the most extreme environments on Earth. As we continue drifting through the quiet volcanic landscapes beneath the sea, something remarkable begins to appear. Up to this point in our journey, we have imagined the deep ocean as a place of darkness, cold, and silence. And in many ways, it truly is. Far below the surface, sunlight disappears completely. Temperatures drop close to freezing, and the pressure of the ocean above presses down with tremendous force. For a long time, scientists believed that very little life could exist in such an environment. But when explorers first discovered hydrothermal vents in the late 20th century, they encountered something astonishing. Instead of empty darkness, they found thriving ecosystems. Entire communities of creatures living directly beside underwater volcanoes. Imagine descending in a deep-sea submersible. Your small research vessel drifts slowly downward through the ocean. Above you, the last traces of sunlight fade away. The water grows darker and colder. Eventually, your lights illuminate the seafloor, and in the distance, you see towering mineral chimneys rising from the volcanic rock. Hydrothermal vents. As your submersible moves closer, the darkness begins to reveal movement. Clusters of strange organisms gather around the vents. Creatures unlike anything seen in shallow waters. This is one of the most unusual ecosystems on Earth. Among the most famous inhabitants of hydrothermal vents are giant tube worms. These creatures look almost like tall white stalks rising from the seafloor. At their tips are bright red plumes that wave gently in the ocean currents. Some tube worms can grow more than 2 meters long, making them among the largest invertebrates found in the deep sea. Yet what makes them truly remarkable is how they survive. Tube worms have no mouth and no digestive system. Instead of eating food in the traditional way, they rely entirely on bacteria living inside their bodies. These bacteria perform chemosynthesis, converting chemicals from the vent fluids into nutrients. In return, the tube worms provide the bacteria with a stable home. It is a partnership that allows both organisms to survive in a place where sunlight never reaches. Surrounding these forests of tube worms are swarms of other strange creatures. One of the most fascinating is the vent shrimp. These small shrimp gather in dense clusters near the warm water flowing from hydrothermal vents. Some species appear almost ghostly pale, while others have faint red or orange coloring. Many of them are nearly blind. In the darkness of the deep sea, eyesight is often unnecessary. Instead, these shrimp use special sensory organs to detect heat and chemicals released by the vents. They gather where the water is warmest, feeding on the bacteria that thrive in the mineral-rich environment. In some vent fields, the shrimp populations become so dense that they appear like moving carpets across the volcanic rock. Thousands of individuals crowd together near the openings where hot fluids escape. The water here may be warm compared to the surrounding ocean, though it remains dangerously hot in places. Yet the shrimp navigate these environments with remarkable precision, staying within the narrow temperature range where they can survive. It is a delicate balance between heat and cold. Other creatures also inhabit these unusual volcanic ecosystems. Deep-sea crabs crawl slowly across the vent chimneys. Small fish glide cautiously through the mineral plumes. Snails and clams anchor themselves to the rocky surfaces near the vents. Each organism plays a role in the ecosystem. Some feed on bacteria, others prey on smaller animals. Together, they form a complex community supported entirely by the chemistry of the Earth itself. What makes these ecosystems truly extraordinary is that they exist without sunlight. In most environments on Earth, life depends on energy from the sunday. Plants capture sunlight through photosynthesis, forming the base of the food chain. Animals then feed on plants or on other animals. But at hydrothermal vents, the sun plays no role at all. Instead, energy comes from deep within the Earth. The chemicals released by underwater volcanoes provide the fuel that supports life. It is a completely different kind of ecosystem, one powered by geology rather than sunlight. Scientists believe that these vent ecosystems may offer clues about how life began on Earth. Billions of years ago, before plants and animals existed, the planet may have looked very different. The oceans were likely filled with volcanic activity and chemical-rich waters. In such environments, simple microbial life may have first emerged. Hydrothermal vents provide a glimpse into what those ancient conditions might have been like. They show us that life can survive, even thrive, in places once thought impossible. The discovery of vent ecosystems has also changed the way scientists think about life elsewhere in the universe. If life can exist in the darkness of Earth's deep oceans, powered only by chemical energy, then perhaps similar environments could support life on other worlds. Some moons in our solar system, such as Europa and Enceladus, are believed to contain oceans beneath their icy surfaces. And if those oceans contain hydrothermal vents, they might also host ecosystems powered by chemistry rather than sunlight. For this reason, hydrothermal vents are not only important for understanding our own planet, they may also help us search for life beyond Earth. But for now, our journey remains here in the deep oceans of our own world. Imagine once again the silent volcanic landscape beneath the sea. Tall vent chimneys rising from the rock, clouds of mineral-rich water drifting upward, and around them, entire communities of strange creatures living quietly in the darkness. Tube worms swaying gently in the currents, shrimp gathering in dense clusters, crabs moving slowly across the seafloor, life thriving in one of the most extreme environments on Earth. And yet, underwater volcanoes are capable of far more than supporting unusual ecosystems. Sometimes, these hidden mountains erupt. Molten rock bursts from cracks in the seafloor, gas bubbles rise through the water, and entire sections of the ocean floor can transform in moments. In our next segment, we will explore what happens during these rare but powerful events, the mysterious world of underwater volcanic eruptions. As our quiet journey through the volcanic world beneath the ocean continues, we now arrive at one of the most powerful events that can occur deep below the sea, an underwater volcanic eruption. When we imagine volcanoes erupting on land, we often picture dramatic explosions, towering columns of ash rising into the sky, rivers of glowing lava pouring down mountainsides, and thunderous sounds echoing across the landscape. But beneath the ocean, volcanic eruptions behave very differently. The deep sea changes everything. Imagine the sea floor resting quietly in darkness. The water above presses down with immense force. Thousands of meters of ocean create pressure so strong that it reshapes the way magma behaves. Deep beneath the crust, molten rock slowly builds within underground chambers. Eventually, pressure increases. Cracks form in the rock, and molten magma begins to rise. At first, the eruption may be gentle. Lava slowly seeps through fractures in the seafloor, spreading outward like thick, glowing rivers. The cold seawater surrounding the lava cools it rapidly, forming the pillow-shaped rocks we explored earlier. These eruptions can continue for hours, days, or even longer, quietly building new layers of oceanic crust. But not all underwater eruptions are slow and calm. Sometimes gases trapped inside the magma escape suddenly. When this happens, the eruption can become more dramatic. As the magma reaches the seafloor, volcanic gases begin to expand. Large bubbles of gas rise upward through the ocean water. These bubbles may contain carbon dioxide, sulfur dioxide, or other volcanic gases released from deep inside the Earth. In some eruptions, the gas bubbles grow so large that they resemble giant shimmering spheres rising toward the surface. They drift upward through the dark water before slowly dissolving into the surrounding ocean. Along with lava and gas, underwater eruptions can also release clouds of volcanic particles. Instead of towering ash plumes rising into the sky, the eruption produces submarine ash clouds that spread through the surrounding water. These clouds are made of tiny fragments of volcanic rock and glass created when magma shatters upon contact with cold seawater. The particles disperse slowly, carried by deep ocean currents. Over time, they settle back onto the seafloor, forming thin layers of volcanic sediment. This quiet snowfall of volcanic ash can blanket large areas of the ocean floor. One of the most fascinating aspects of underwater eruptions is the way water pressure influences the eruption itself. In deep water, the immense pressure suppresses many of the explosive forces that make volcanoes on land so dramatic. The water acts almost like a giant lid containing the eruption. Instead of violent explosions, many deep-sea eruptions produce slow-moving lava flows. This allows the magma to cool gradually, building new crust layer by layer. In this way, the deep ocean creates a very different kind of volcanic environment. However, when eruptions occur in shallower water, the situation changes. If a submarine volcano lies closer to the ocean surface, the pressure of the water is much lower. This allows gases inside the magma to expand more freely. As a result, eruptions can become far more explosive. Water and magma interact violently, producing bursts of steam and fragmented rock. These events are sometimes called phreatomagmatic eruptions. They occur when hot magma encounters seawater and flashes it instantly into steam. The sudden expansion can shatter the magma into fine fragments and send debris outward in turbulent clouds. Some of the most dramatic underwater eruptions happen when a growing submarine volcano approaches the ocean surface. At this stage, the interaction between magma and water can create enormous plumes of steam and ash. Eventually, repeated eruptions may pile enough volcanic material above the waterline to create a new island. This is how some volcanic islands first appear. At first, the eruption occurs entirely underwater. Then, gradually, the growing volcanic cone breaks the surface of the ocean. Suddenly, what was once hidden beneath the sea becomes visible to the world. These island-forming eruptions have been witnessed several times in modern history. In some cases, new islands appear suddenly after a powerful submarine eruption. The ocean's surface may churn with bubbles and floating pumice. Steam clouds rise into the sky. Within days or weeks, a small island of fresh volcanic rock emerges from the sea. Some of these islands last for centuries. Others are quickly eroded away by waves and storms. But each one begins the same way through volcanic eruptions beneath the ocean. Even when underwater eruptions remain hidden from view, scientists can detect them. Special instruments placed on the ocean floor can record seismic activity, temperature changes, and chemical signals. Submarine eruptions often produce earthquakes as magma moves through cracks in the crust. They also release heat and minerals into the surrounding water. In recent years, Autonomous underwater vehicles and robotic explorers have allowed scientists to observe these eruptions more closely than ever before. Some cameras have even captured glowing lava flowing across the deep seafloor in real time. Watching lava erupt in the darkness of the deep ocean is a strange and beautiful sight. The molten rock glows briefly against the black water. Steam and mineral clouds swirl around the eruption. Then, slowly, the lava cools and hardens. Within hours, the glowing flow becomes solid rock once again, another small piece of Earth's crust added quietly beneath the sea. Over millions of years, countless eruptions like these have shaped the ocean floor. Each one contributes to the ever-changing landscape beneath the waves. Volcanic ridges grow, seamounts rise, new crust forms, and the planet continues its slow transformation, all hidden beneath the vast and silent oceans. But not every underwater volcano erupts violently. Many simply grow slowly over time, building enormous underwater mountains. Some of these mountains never reach the surface of the ocean. Instead, they remain hidden far below the waves. These mysterious volcanic mountains are known as seamounts. And in our next segment, we will explore these remarkable underwater peaks, the towering mountains of the deep sea. As we continue drifting through the volcanic landscapes beneath the ocean, our journey now leads us to some of the most mysterious mountains on Earth. Mountains that few people have ever seen. Mountains that rise silently from the dark seafloor. Mountains that may be taller than those on land, yet remain hidden beneath kilometers of water. These underwater mountains are known as seamounts, and they are among the most fascinating geological structures beneath the sea. Imagine the deep ocean floor once again. The darkness stretches in every direction. The water above is heavy with pressure, and from the seabed, enormous volcanic mountains rise upward. Some of these mountains climb thousands of meters from the ocean floor, yet their peaks never reach the surface. They remain permanently submerged, silent giants hidden beneath the waves. These are the seamounts. Most seamounts begin their lives as underwater volcanoes. Deep within the Earth's mantle, magma slowly rises through the crust. When this molten rock erupts on the seafloor again and again, layers of volcanic material accumulate. Over time, the volcano grows taller. Each eruption adds more lava. Each lava flow spreads across the slopes of the growing mountain. Slowly, over thousands or millions of years, the volcano builds itself upward from the ocean floor. Some seamounts become enormous. In fact, many of them are far larger than mountains we see on land. One famous example is Mauna Kea, part of the Hawaiian volcanic chain. If measured from its base on the ocean floor to its summit above sea level, Mauna Kea rises more than 10,000 meters. That is taller than Mount Everest when measured from base to peak. Yet most of this enormous mountain remains hidden beneath the ocean. But not every underwater volcano grows high enough to become an island. Many seamounts stop growing long before they reach the surface. Their eruptions slow or cease. The volcano becomes inactive, and the mountain remains permanently beneath the sea. Over time, currents and sediments slowly reshape its slopes. The peak may flatten, the rock may become covered in marine life, yet the mountain itself remains a silent reminder of ancient volcanic activity. Across the world's oceans, scientists believe there may be more than 100,000 seamounts. Many have never been explored. Some have not even been mapped. They form vast chains across the ocean floor, often following the paths of ancient volcanic activity. These mountains create one of the most complex and varied landscapes on Earth. Yet much of it remains hidden in the darkness beneath the sea. Some seamount chains form along hotspots deep within the Earth's mantle. A hotspot is a place where hot material rises steadily upward from deep inside the planet. As tectonic plates slowly drift across these hotspots, volcanoes form one after another. Each new volcano appears above the hotspot, erupts for a time, and then moves away as the plate continues to shift. The result is a chain of volcanic mountains stretching across the ocean floor. The Hawaiian Islands are a famous example of this process. The islands themselves are only the newest peaks in a long chain of seamounts that extend far across the Pacific Ocean. Most of those mountains lie far beneath the sea. Seamounts are not only geological wonders, they are also important habitats for marine life. When ocean currents encounter these underwater mountains, the flow of water is disturbed. Nutrients from deeper waters are carried upward. This creates rich feeding grounds for many ocean creatures. As a result, seamounts often support diverse ecosystems. Coral colonies grow along their slopes. Schools of fish gather around their peaks. Crabs, starfish, and many other organisms make their homes among the volcanic rock. In the vast emptiness of the deep ocean, seamounts become islands of life. Some marine species rely on seamounts as important stopping points during long migrations. Fish, sharks, and even whales may gather near these underwater mountains. The complex terrain creates hiding places and feeding opportunities. In some regions, seamount ecosystems rival the biodiversity found in coral reefs. Yet because they are so difficult to reach, many of these habitats remain poorly understood. Scientists continue to discover new species living among these underwater peaks. But seamounts also face challenges. Because they attract large numbers of fish, they have become targets for deep-sea fishing. Some seamount ecosystems grow extremely slowly. Cold water corals may take hundreds or even thousands of years to develop. If damaged, these fragile habitats can take centuries to recover. For this reason, many scientists advocate protecting seamount ecosystems as important parts of the ocean's biodiversity. Despite their importance, much of the seamount world remains unexplored. The ocean is vast, and the technology required to study deep underwater mountains is still limited. Even today, new seamounts are being discovered. Each one offers a glimpse into a hidden landscape shaped by ancient volcanic forces, towering mountains rising silently from the depths. So imagine once again the quiet ocean stretching across the night. From the surface, the sea appears smooth and calm, but far below, an entire world of mountains rises from the seafloor. Volcanic peaks hidden in darkness, some long extinct, others perhaps still slowly growing. Each one a reminder that the ocean floor is far from flat. It is a landscape of enormous volcanic structures, and sometimes, when a seamount grows tall enough, it eventually breaks through the surface of the ocean. When that happens, something extraordinary occurs. A new island is born. In our next segment, we will explore how underwater volcanoes create islands, transforming hidden mountains beneath the sea into land rising above the waves. As our slow journey through the volcanic world beneath the oceans continues, we now arrive at one of the most dramatic transformations the Earth can produce. A mountain rising from the deep ocean, growing slowly, eruption by eruption, until one day it finally breaks through the surface of the sea. And when that happens, a new island is born. Imagine the ocean once again. From the surface, the water stretches endlessly toward the horizon. The waves move quietly beneath the sky. But far below, hidden beneath thousands of meters of water, a volcano has been growing. For centuries, perhaps even thousands of years, lava has flowed from cracks in the seafloor. Each eruption adds another layer of rock. The mountain grows taller, slowly, almost invisibly. But eventually, if the eruptions continue long enough, something remarkable happens. The volcanic peak reaches the surface of the ocean, and suddenly, what was once hidden beneath the sea becomes visible to the world. This is how many of the volcanic islands on Earth first formed. One of the most famous examples is the chain of islands in the Central Pacific Ocean known as Hawaii. But the islands we see above the water today are only the very tips of enormous volcanic mountains. Beneath the ocean, each Hawaiian island sits on top of a massive underwater volcano that rises thousands of meters from the seafloor. Over millions of years, repeated eruptions built these mountains higher and higher until they emerged above the ocean surface. The islands we know today are simply the peaks of these colossal volcanic structures. Hawaii itself sits above a deep mantle hotspot, an area where hot material rises steadily from deep inside the Earth. As the Pacific tectonic plate slowly moves across this hotspot, new volcanoes form one after another. Over time, this process creates a long chain of volcanic islands and seamounts. The youngest islands sit directly above the hotspot. Older islands slowly drift away as the plate moves. Eventually, the volcanoes become inactive. The islands begin to erode, and the cycle continues as new volcanoes form elsewhere along the chain. Another remarkable example of volcanic island formation is Iceland. Unlike Hawaii, Iceland sits directly on top of the Mid-Atlantic Ridge, the enormous underwater mountain chain where tectonic plates are slowly pulling apart. Here, magma rises continuously from deep within the Earth. This constant volcanic activity has built a large island directly on top of the ridge. Iceland is one of the few places on Earth where the mid-ocean ridge actually rises above the ocean surface. Standing on Iceland's volcanic landscapes, you are literally standing on a place where the Earth is still being formed. But not all volcanic islands have existed for millions of years. Sometimes, entirely new islands appear suddenly in the ocean. These events occur when a submarine volcano erupts with enough force and enough material to rise above the sea. At first, the eruption happens beneath the water. Bubbles of volcanic gas rise to the surface. The ocean may begin to churn and foam. Floating pumice-light volcanic rock filled with gas bubbles may drift across the waves. Then, gradually, a small mound of volcanic rock appears above the waterline. A newborn island. In some cases, these islands grow rapidly during intense eruptions. Within days or weeks, lava and ash accumulate above the ocean surface. Steam clouds rise where magma meets seawater. The sea around the eruption may turn dark with volcanic particles. Eventually, the eruption subsides. What remains is a fresh island made of newly formed volcanic rock. A brand new piece of land where there was once only open ocean. One famous example occurred in 1963 when an underwater volcano erupted south of Iceland. For several days, powerful explosions sent steam and ash high into the sky. Gradually, volcanic material accumulated above the surface of the sea. By the end of the eruption, a new island had formed. Scientists named it Surtsey. Surtsey became an extraordinary natural laboratory where researchers could observe how life gradually colonizes a brand new island. Over the years, birds arrived. Plants began to grow. And slowly, the island transformed from bare volcanic rock into a living ecosystem. However, not all new volcanic islands survive. The ocean is a powerful force. Waves and storms can quickly erode freshly formed volcanic rock. Some newborn islands disappear within months or years after their eruptions end. The sea slowly breaks them apart and carries the volcanic debris back into the water. In these cases, the island exists only briefly before returning to the ocean once again. Yet, even when an island disappears from view, the volcano beneath the sea often remains. The mountain may still rise from the ocean floor. Its summit just below the surface, silent, dormant, waiting for the next eruption. Over geological time, these underwater volcanoes may erupt again. If enough lava accumulates, the mountain may once again rise above the waves. Another island may be born, Across the oceans, countless volcanic mountains are slowly building in this way. Some will never reach the surface. Others may eventually emerge as islands far in the future. The process is slow, sometimes taking millions of years, but it is one of the ways our planet continues to reshape itself, quietly building new land from the depths of the sea. And yet, many of these island-forming volcanoes lie within one particular region of the planet where volcanic activity is especially intense. A region known as the Ring of Fire. There, beneath the oceans of the Pacific, powerful tectonic forces drive earthquakes, volcanic eruptions, and the creation of new ocean crust. In our next segment, we will explore this vast and restless volcanic belt, the hidden Ring of Fire beneath the ocean. As we continue drifting through the volcanic landscapes hidden beneath the oceans, our journey now leads us to one of the most powerful geological regions on Earth. A vast belt of volcanoes and earthquakes that circles much of the Pacific Ocean. Scientists call this region the Pacific Ring of Fire. From the surface of the planet, it stretches across continents and islands from the coasts of South America and North America, across the Aleutian Islands, through Japan, the Philippines, Indonesia, and down toward New Zealand. But much of this ring does not lie on land. Large portions of it are hidden beneath the sea. Deep below the ocean surface, powerful forces are constantly shaping the Earth's crust. To understand the Ring of Fire, we must first imagine the Earth's outer shell. The planet's crust is not a single solid piece. Instead, it is divided into enormous sections called tectonic plates. These plates slowly move across the surface of the Earth. Some drift apart, some slide past one another, and in certain places, one plate sinks beneath another. This last process is known as subduction. Subduction zones are among the most important and dramatic places in Earth's geology. In these regions, one tectonic plate gradually slides beneath another and descends deep into the mantle. The sinking plate carries oceanic crust, sediments, and water downward into the Earth's interior. As the rock descends and heats up, parts of it begin to melt. This molten material rises through the crust, eventually forming volcanoes. Many of the volcanoes in the Ring of Fire are created through this process. Beneath the ocean surrounding the Pacific, enormous subduction zones stretch for thousands of kilometers. Here, entire sections of oceanic crust slowly sink into the mantle. Above these zones, chains of volcanoes form. Some rise high enough to become volcanic islands. Others remain hidden beneath the sea. Together, they create vast volcanic arcs that trace the boundaries between tectonic plates. This is why the Ring of Fire contains such a high concentration of volcanoes. In fact, around 75% of the world's active volcanoes lie within this region. The Ring of Fire is also responsible for many of the world's earthquakes. As tectonic plates grind slowly against each other, stress builds within the crust. Eventually, that stress is released in sudden movements along faults. These movements create earthquakes. When they occur beneath the ocean floor, the effects can be felt across vast distances. Sometimes the seafloor shifts suddenly during a powerful underwater earthquake. This movement can displace enormous volumes of water. The result may be a tsunami, a series of powerful ocean waves capable of traveling thousands of kilometers across the sea. Yet even though the Ring of Fire is associated with powerful geological events, most of the time its processes unfold slowly and quietly. Deep beneath the ocean floor, tectonic plates move only a few centimeters each year. Subduction occurs gradually. Magma rises slowly through the crust. And underwater volcanoes erupt far from human observation. Much of this activity takes place in darkness, hidden beneath kilometers of water. It is a reminder that the Earth is constantly evolving, even when we cannot see it. The seafloor along the Ring of Fire is a landscape shaped by these immense forces. volcanic mountains rise from the depths. Deep ocean trenches mark the places where plates descend into the mantle. Some trenches are among the deepest places on Earth. The Mariana Trench, for example, plunges nearly 11,000 meters below the ocean surface. At such depths, the pressure is unimaginable. Yet even here, the tectonic forces of the planet continue their slow work. The Ring of Fire also connects many of the volcanic islands we know today. Japan, Indonesia, the Philippines, and the Aleutian Islands are all part of volcanic arcs formed above subduction zones. These islands represent the visible peaks of volcanic systems that extend deep beneath the ocean floor. Beneath each island lies a much larger volcanic structure hidden beneath the sea. In this way, the islands of the Pacific are only small glimpses of a vast geological network below. For scientists, the Ring of Fire is an extraordinary place to study the inner workings of the Earth. By observing volcanic eruptions, earthquakes, and seafloor movements, researchers can learn how tectonic plates interact and how the planet releases heat from its interior. Submersible vehicles, seafloor sensors, and satellite measurements all contribute to our understanding of these processes. Even so, much of the Ring of Fire remains unexplored. The oceans are vast, and the depths still hold many mysteries. As we imagine the quiet ocean stretching across the night sky, it is difficult to picture the powerful geological activity occurring far below. But beneath those calm waters, tectonic plates continue their slow movements. Volcanoes form and erupt. Mountains rise from the seafloor, and the Earth reshapes itself in ways that unfold across millions of years. The Ring of Fire is one of the clearest reminders that our planet is not a static world. It is alive with motion and change. And yet, despite all this volcanic activity beneath the oceans, the seafloor continues to evolve in subtle ways over immense periods of time. New crust forms. Old crust sinks into the mantle. Volcanic mountains grow and erode. The ocean floor itself is constantly transforming. In our final segment tonight, we will explore how this quiet geological process continues to reshape the ever-changing ocean floor. As we arrive at the final chapter of our journey tonight, let us pause once more and imagine the quiet surface of the ocean. The waves move gently beneath the moonlight. From above, the sea appears calm, almost timeless. It is easy to believe that the world beneath the water must be just as still. But far below the surface, beneath kilometers of dark ocean, the Earth is constantly changing. The ocean floor is not fixed. It is not permanent. It is part of a slow and ongoing transformation that has been shaping our planet for hundreds of millions of years. Deep beneath the sea, the Earth's crust is continually being created and destroyed. Along the mid-ocean ridges we explored earlier, molten rock rises from the mantle and cools into new oceanic crust. Each eruption adds another thin layer of basalt to the seafloor. Over time, these layers accumulate. New sections of the ocean floor slowly spread outward from the ridges. This process, known as seafloor spreading, is one of the fundamental forces that shape our planet. Imagine the ocean floor moving outward from a mid-ocean ridge like a slowly moving conveyor belt. Fresh rock forms at the center. Older rock drifts gradually away. The movement is incredibly slow, usually only a few centimeters per year. But across millions of years, this steady motion reshapes entire oceans. Sections of crust that were once near the center of the ocean basin may eventually travel thousands of kilometers before reaching the edges of tectonic plates. Eventually, this ancient oceanic crust reaches regions known as subduction zones. Here, the seafloor begins its final journey. The tectonic plate carrying the crust bends downward and sinks beneath another plate. Slowly, the ocean floor disappears into the mantle. The rock that once formed from volcanic eruptions is recycled back into the Earth. This continuous cycle of creation and destruction is part of the planet's natural rhythm. New crust forms, old crust sinks, and the cycle continues. Because of this process, the ocean floor is surprisingly young in geological terms. The oldest sections of oceanic crust are only about 200 million years old. Compared with continents which may contain rocks billions of years old, the ocean floor is constantly being renewed. The seafloor we see today is only the most recent chapter in a long geological story. Earlier ocean floors have already disappeared into the mantle over the vast stretches of time. As new crust forms along the mid-ocean ridges, underwater volcanoes continue to emerge. Some remain small. Others grow into massive volcanic mountains rising from the seafloor. Occasionally, new volcanic structures appear where none existed before. These volcanoes may erupt quietly beneath the ocean for thousands of years before anyone discovers them. Sometimes scientists detect them only through subtle clues, small earthquakes, changes in water temperature, or unusual chemical signals in the ocean. Hidden volcanic systems may be forming right now somewhere on the seafloor. In certain regions, entire volcanic chains are created as tectonic plates drift across mantle hotspots. Each new volcano forms above the rising plume of hot rock deep within the earth. As the plate moves, the volcano eventually drifts away from the hotspot and becomes inactive, but a new volcano forms behind it. Over time, this process creates long lines of seamounts and islands stretching across the ocean floor. The Hawaiian island chain is one example of this slow volcanic migration. Beneath the ocean beyond Hawaii, dozens of older volcanic mountains trace the path of the moving plate. The seafloor itself is also shaped by deep ocean currents and the gradual accumulation of sediments. Tiny particles drift downward through the water remnants of plankton shells, fragments of rock, and dust carried by the wind from distant continents. Over thousands of years, these particles settle onto the ocean floor like a slow snowfall. Layer by layer, the sediments blanket older volcanic rocks. In some places, these layers grow hundreds of meters thick. The once rugged volcanic landscape becomes softened by time. Yet even as sediments accumulate, the forces beneath the Earth's crust continue their slow work. Magma rises, plates move, mountains grow and sink. The ocean floor is never truly at rest. It is a dynamic landscape shaped by heat, pressure, and time. And because much of it lies hidden beneath kilometers of water, many of its changes remain unseen. Modern technology has begun to reveal this hidden world in remarkable detail. Using sonar mapping, satellite measurements, and robotic submersibles, scientists can now create detailed maps of the seafloor. These maps show vast mountain ranges, deep trenches, and enormous volcanic structures stretching across the oceans. Yet even today, large portions of the ocean floor remain unexplored. In fact, scientists know more about the surface of the Moon and Mars than they do about many parts of Earth's deep oceans. Every new expedition reveals something unexpected: a previously unknown seamount, a hydrothermal vent field filled with unusual life, or evidence of a recent volcanic eruption that reshaped part of the seafloor. These discoveries remind us that our planet is still full of mysteries. Even here on Earth, there are landscapes that few humans have ever seen. Over millions of years, the movements of tectonic plates continue to reshape the oceans themselves. Continents slowly drift across the globe. Ocean basins open and close. Mountain ranges rise and erode. The surface of the Earth is constantly evolving. What we see today is only a temporary arrangement in the long geological history of the planet. The oceans of the future may look very different from the ones we know today. New islands may appear, others may disappear beneath the waves, and the ocean floor will continue its slow transformation. And so, as we reach the end of our exploration tonight, imagine the deep ocean once more. Beneath the calm surface of the sea lies an entire world of volcanic mountains, spreading ridges, hydrothermal vents, and hidden ecosystems. A landscape shaped by fire and water, a place where the Earth quietly builds and rebuilds its own surface. Even now, far below the waves, magma may be rising through the crust. New rock may be forming. A volcano may be growing slowly in the darkness. Another small step in the long evolution of our planet. And as you drift towards sleep tonight, imagine that quiet transformation continuing far beneath the ocean. The seafloor slowly moving, volcanoes rising, mountains forming where no human eye has ever seen, the Earth reshaping itself beneath the silent sea. Next, we will close our journey with a quiet reflection on this hidden world beneath the waves, and the peaceful rhythm of a planet that is always changing. As our quiet exploration of underwater volcanoes slowly comes to an end tonight, let us return once more to the surface of the ocean. Imagine the sea stretching calmly beneath the night sky. The waves move slowly across the water. Moonlight glimmers softly across the surface. From above, the ocean appears peaceful, almost perfectly still. It is easy to believe that nothing much is happening beneath those gentle waves. But now we know that far below the surface, the Earth is alive with motion. Hidden beneath kilometers of water lies a world of volcanic mountains, glowing magma and slowly shifting crust. A world shaped by fire beneath the sea. Deep beneath the calm ocean surface, molten rock continues to rise through the Earth's crust. Underwater volcanoes quietly release lava into the darkness. New sections of ocean floor slowly form. Ancient crust sinks back into the mantle, and towering volcanic mountains grow unseen beneath the waves. All of it happening slowly, patiently, over immense spans of time. The planet reshaping itself, one eruption at a time. Most of the time, we never notice these changes. The ocean hides them well. From the shoreline, the sea appears tranquil and timeless. But beneath that calm surface lies a powerful geological engine that has been shaping our world for billions of years. Underwater volcanoes create new crust. They build islands. They form mountains on the seafloor. They release heat from deep within the Earth. In many ways, they help define the very shape of our planet. And perhaps that is one of the most peaceful thoughts we can carry into sleep tonight. Even when the surface of the world seems still, deep below there is quiet movement and transformation. The Earth continues its slow work. Mountains rise in darkness. Lava cools into new stone. And the ocean floor gradually becomes something new. So as you begin to drift into rest, imagine the deep ocean once more. The water above is calm. The darkness below is vast. And far beneath the waves, hidden volcanoes glow softly in the silent depths. Molten rock, slowly building mountains in the darkness. A quiet world of fire beneath the sea. Now let your thoughts slow and settle like drifting particles in the deep ocean. Allow the rhythm of the waves to guide your breathing. In a moment, the ambient ocean sounds will continue, helping you relax even further. Good night. Sleep peacefully, and may your dreams drift gently across the quiet oceans of our ever-changing planet.